Time to shine again, y'all. We're back at the car wash. CB here. No BS welder, NBS welding. So years ago when they built the car wash, we built these pay stations. My part of the pay station obviously is the steel part. Here to protect the pay station, you know, and prevent a vehicle from being able to smash into that block and wreck that computer or that machine or whatever. It's important because it takes your money, and if you don't pay for the car wash, then my buddies that spend a lot of money running this place, they'd have a real problem. So, you know, we're gonna try to protect that. And so here's the thing, if you've been following the channel, we got them some structural steel for their addition that they're putting on here. And just to tell you what they're doing, this is a soft touch unit with the brushes. And a lot of people really like this. It does a nice job. These brushes whirl around, and they got a high quality soap or chemical, whatever, that shoots out and it washes your car for you like a hand wash. But some people don't want those brushes contacting their car. Now there's another option that you can do with a high pressure unit, and that's what they're putting in here. So when you pull up here, if you want the brushes, you do the brushes. If you want the pressure, you do the pressure. So that's what's going on. That's what the addition is. This is going to be a completely touchless. And the way that it will get the dirt off your vehicle is by massive pressure. No brushes. So that's what the addition's about. And we got to do, see, there's no guard for the pay station here. There's just a big hole where it's supposed to be. So we got to build another one of those. Is one of the main doozens we got to get done. And another thing is, come in the bay here, we give us a look, see where the water's going to go. We got to make them some grating for this trough. So this would be a bar grating product. We'll have to get cut to size and put in here. So that's another doozen we got to get done. Now let me take you over here where the vacs are. Been a couple videos I done on this setup. We built this awning. I fabbed all this steel. I actually got shots the crane setting this whole thing. Because I built all this on jack stands down here on the ground, and we lifted it up with the crane and welded everything up. Okay, but what they've done moving forward with this is they got the vacuums put in, and some of you might remember recently I was here and welded in those brackets that secures the top of these posts. And another thing, here's the thing we're going to be doozing on this, is if you see how these posts are set up, they've got this gizmo where this is where your vacuum hose goes in the holster there. Here's the problem. We've got the curb that you pull up to, and these hoses get over here like this. And guess what happens then? Somebody's going to pull up here with their tire, and they're going to squish the hose. And that would basically be what we'd call a bad doozination, or an improper doozination, when stuff is getting mixquishulated like that. So here's the idea that my buddy got. He would like to have those holders on these poles, because see, if this was over here, that gets it away from the curb where that's not going to be an issue. He was thinking with his dipstick there, because that's what needs done. That's a good idea. That's going to fix the problem. And the way I think I'm going to go about doing it, if you look at what they got here, you would say, well, just cut that off of there and put it on over there. But I don't think I'm gonna. I think I'm gonna make new ones. The way this is all polished and everything, if I cut that off there, I think this part of the post is gonna look bad, and I don't know if I could polish it to get it to look exactly like it is. You know, leaving this alone and leaving that on there and just unbolting this, that wouldn't hurt nothing. We could even put something else on this plate. We could put a sign there that says "Have a nice day" with a smiley face. Wouldn't that be cool? I mean, everybody needs a smiley face. Okay, I'm making up shit, but I'm just saying we could do something besides make a bunch of work there, because really over here, this is under roof and all of this is painted mild steel. So there's no, as far as having that over here, there's nothing to gain by that being stainless. And you know, a mild steel plate with 4 holes in it and 13 inches of mild steel pipe, that's nothing. That's probably stuff I got laying on the floor, laying in the floor or out in the gravel or something. So I say I'm going to make, we got 4 posts. There's 4 of those steel posts in here. I'm going to make 4 of those pipes with plates on them. And now the 2 on the outside will only have 2 holes instead of 4. And what we'll be doing is, actually we would take this bracket and put over there, and then take this bracket and put on the right side of the one here. See where it says, can you smell what I'm stepping in? Because then that one goes there and then that one goes there. Got that worked out. That's going to work. And like I say, I think it's better just to leave that stainless on there and not fool with the polish. We'll just unbolt the holster, bolt it on the new bracket after I weld it on the post. And there's no point in having a stainless steel bracket welded to that mild steel post. You know, we'll just paint it just like this steel here is, and it's under roof. I mean, this paint like this oil-based paint on steel, when it's under roof like this, it'll last a long time. It's not got a heavy amount of sun or rain or ice exposure because of the roof, and it's going to be fine. So that's the doozin' we got to get done. 3 projects pretty much coming up for the car wash. Let's get to work. Alright then, so we got to get cracking on cutting up some pipe. I got a plan. Let's take a look. Took some measurements when I was down there, and this is pretty much what we're going to be looking at on the pay station part. And this is tell us pretty much what we need to get going on a cut list. But to make that life size, I've drawn it out here on the table. So this would be we need two legs like this. That's got, you know, the vertical piece and its support. And then we got our pipe in here, and we're going to be cutting up the pipe. There's a cope right here that we're going to have to torch cut. I've got a 22.5 degree miter right there that in this case we can saw cut. Cutting up some 4-inch pipe on the rolling rig with the 872 DeWalt chop saws. Just getting things mark the length. I've got a cut list that I made using the drawing that I drew on the table. Yeah, it'll tell me a little bit about my angle cuts and what I need to know, and I can carry pieces over there. You can see where I took that one piece and set it on the drawing, see if it was fitting. Obviously, if I'm cutting more than one part like that, it's worth checking the first one. See if I'm doing it right before I cut a bunch of them wrong. Those pieces cut, there's several that get a cope fit, which has got to be done with oxyacetylene torch. And I got them marked with soapstone and burn them out with triple aught tip. I've done some videos about tip cleaning. Your clean tip is one of the things that you just, when it comes to cutting with oxyacetylene, you got to have a clean tip. And having a tip cleaner, knowing how to use it, best trick I've got is to blow a little oxygen when you're cleaning that center hole. That seems to get the debris out of them really well. You can see my mark there that I'm following. That's from a pattern. I have actually had a cope pattern. And some of those straight copes, I'll show you later, they can be cut on a saw. Not all the copes can be cut on a saw. A lot of them you got to do with oxyacetylene, or you could use a plasma cutter or cutting wheel on a grinder. There's lots of different ways. I like to cut with oxyacetylene. Been doing it for a long time, and I'm just used to it, having that torch in my hand. I would actually prefer an oxyacetylene torch to a plasma on stuff like this. Plasma is a lot faster in some cases, especially on sheet. But I'm not crazy about it on pipe. Here we're taking a look at my drawing and my jig. You can see where I've tacked some angle iron on the table to push my pipes against. And if you don't do that, and you're trying to use a drawing, especially with pipe, it's hard to get them lined up. And I was just saying that I tacked some angle iron clips on the table, but I can see in that part of the video, I hadn't tacked them on yet. I just got them laying there. But I did tack them on based on my marks on the drawing that I made on the table. And once they were tacked on there, that helped me to get my parts in place. And you can use those clips to clamp your parts, which helps too. And you can see here, it's this first one I'm putting together, getting it welded up. And I think I had tacked it to a couple of the clips, but when I did the second one, I didn't tack it down. I didn't feel like I needed to. Using the grinder to open up a gap a little bit. Don't want it fitting too tight. I want to get some penetration on it. And some of these I welded downhill, and some of them I welded uphill, depending on what kind of a gap. I know on the end of this miter right here, I had ended up running a lot of uphill, and on some of it, I was jogging the trigger. You can see where I stopped welding briefly a few times right there, running uphill. The reason I was doing that is because I'm actually got my machine set on too much heat to run uphill. Now I could have went over there and turned the machine down, but then I would have been too cold to run it downhill. So I do have a tendency sometimes, if I got a tight gap and I'm running an uphill, instead of turning the machine down, I might jog the trigger a little bit. You can let off the trigger, let your material cool just a little, and go back to it. You can see on this part, there's a lot of flat welding and a lot of manipulation. Those welds on that fitter are quite a bit wider than others. And this is just a quick video of the whole thing sort of on that second one being put together rather than just pieces of video. And then we're getting our caps cut. We need 4 of those caps for that 4-inch pipe. So I'm using my pattern I had already had made for my pattern torch for caps for 4-inch pipe, and running the old school pattern torch to burn some caps out. It does a nice job, that old machine. Gonna try stick welding with the Arc Captain MiG 145. Now you'll see I get this up there and I get a couple tacks on it. With the brand new rod, it lights up okay and makes a tack. The tack wasn't shielded very good. It had some porosity, but it did all right. And it's a little easier with a new rod to make a tack. But after you've made a couple tacks with a rod, it takes a lot more open current voltage to get it lit. And as you'll see here, this machine doesn't want me to light up that used rod. I tried turning the amps up some, and that may have helped, but not a lot. And then I realized that it made it way too hot, because once you get it burning, it burns fine. I finally got the 3 tacks on it and then struggled to get the rod lit. And I get it welding, and I burn about half of that 3/32 7018 and kick the breaker. It's a 20 amp breaker, 12 gauge wire, pretty standard. And that was upsetting. Running the flux core that I've run with this machine, I can run 100 amps with 030 flux core and weld pretty hot. And there's not a breaker issue, but we've got one with the stick. And I realized that the welding positioner was plugged into the same circuit that the Arc Captain was. And to give it a better chance, I unplugged that cord that the Arc Captain was plugged into and plugged it into the wall in a completely different circuit. So on this next try, it's on its own 20 amp circuit without anything else running. And here again, struggling to get a rod lit, burn a half a rod, and kick the breaker. Now, there's probably things we can do with rod selection and rod size that'll get this thing running on a 20 amp. But if it won't burn a 332 7018 on a 20 amp breaker, it's not a very viable stick welder in my opinion. So here's my next question with the Arc Captain MiG 145 on this job. If I can't run a 3/32 7018 on that 20 amp breaker and get this done that way, can I hook it back up like I was running it with the 030 flux core and do the job? We're about to find out. Got the Arc Captain MiG 145 loaded up with the Arc Captain 030 flux core wire, and hit the foot pedal on that welding positioner, started turning the pipe, pulled the trigger on that Arc Captain gun, started running the flux core wire. I'm on 100 amps, no problem kicking the breaker, no problem penetrating, making the weld. Did a fine job. That's a pretty good amount of do's and done for the first day on this. Especially since we messed with that Arc Captain a little bit. I've been wanting to stick weld with that and see what happened. But we got to shut things down now, and we'll get back on this tomorrow. Tina and the neighbor boys are going to be bobbing for apples here in a little bit, and I can't miss that. Moving on with this pay station roof. We're looking at a side view of this. We got our 80.5 inch pieces up here on the table, and those are the ones that we got the caps welded on. So one of the things we're going to have is a pipe that goes between them, and that's going to get welded to our vertical posts that we've already made, and it's going to be 12 inches from the end of the pipe. So from those caps this way, we'll put a mark at 12 inches and we'll run a pipe across there. We got to do a straight cope on each end of this pipe. And I cut this to length, and I had this piece right here left over. So I'm using it as a test piece. And what I did, I did a saw cope on it, and it's not fitting that great. I mean, it'd work. I could weld that up, but it's not great. But what I did, just to try it, I set that saw at 22.5 degrees. And I put this pipe up there. And I took a slice off. And then I turned it 180 degrees and I took another slice off. And one of the tricks that you can do with this pipe when you do that is look at your welded seam. Because if you've got a line of cope up to where it's lined up between this end and that welded seam, see on the top I can see it because it's blue. On the inside I can see it because it's actually a weld. There's a hump there. But it's a straight line down the pipe. So that's something I would use. I could use that as a reference without having to make marks or use a center head to get those lined up. So what's the problem with what I did on my test piece is the cope's not deep enough. So if I did that at 22.5 and the cope's not deep enough, let's try 30. Yeah. It's just scrap. Let's try it. That went real good. I'm going to hold it up there and we'll have a look. Pretty nice. That's going to be nice to weld that up. Moving on. Got a piece of the 1" by 2" rectangular tubing that's going to be running across the top here to screw that roofing to. And I'm using a piece of scrap pipe to put a mark on it. Now that mark is a radius, and obviously where it needs to fit the pipe is a radius. But on something that small, I can actually just make a miter cut on the chop saw, and it's going to fit just fine without going through the trouble of actually cutting the radius. So I just line it up with the saw from the soapstone mark best I can and make me a cut. Everything else will get filled in with a MIG welder. Then I can use this scrap piece, holding it flush at the top, put a couple marks on the pipe here that'll show the end of the long point. Throw the tape measure up there and measure from those soapstone marks, and it tells me how long that I need to cut these pieces. So I'll take all the pieces, cut the miters on them with my measurement that I just got, and get those ready to go in place. I've made some marks on our pipe, marks that'll show me where to set these, and once they're all set in place, I'll run around and get some tacks on everything, and I can start welding this stuff up. And I go ahead and get the top side of this thing welded. Took it outside and I used the jack stands to hold my piece on the angle that it needed. That way that the post, as I put them on, would just go on plumb. I was able to use that 2-foot level I got that's got a magnet on it. And this first piece, when I set it, kind of fought me, and the second one was real easy. That's just the way it goes sometimes. But you'll notice what I'm using here is a winch, wireless winch. That's the wireless winch rig for the tractor derrick, actually. But I just used some real strong clamps to clamp it onto the forklift, and with it clamped on the forklift fork, it gave me a wireless remote there in hand that I could use to set these pieces by myself. I got this thing moved around where I'm going to do the next step. The last step was welding the bottom. I didn't film welding the bottom, but I'm going to show you. All of these welds under here needed done, so I got all those. And where I had welded one pass on these out in the wind, I had some porosity and stuff, so I welded over that. So that's real good now. Welded the bottom here. I'll probably do some grinding on the outside corners of my miter. A lot of times on a miter cut like that, I'll do sanding and grinding on the outside, leave the inside, because like this is going to look fine with paint on it, but I don't like them. The weld that sticks out on the outer corner of a miter looks nice a lot of times if you sand that off. And I got some 6-inch I-beams I've cut, and I'm going to run them across right here. And because I'm wanting to make this flat on the bottom. And I hope my buddy's not upset with me. I'm actually doing this different than we talked about, because he was talking about, when I asked him how deep he wanted these posts in the concrete, he was saying 2 foot. And I don't think there's anything wrong with having 2 foot of concrete, but I don't think you need that 2 foot of post. If you got I-beams like that ran across here and they're cemented in, actually, I can tell you that where I've got this rebar tacked across here, I put that on there holding the width, but I'll just leave it. They can put that in the concrete too. That's about 8 inches below the level of the top of the concrete is where that rebar will be. It's about 8'8" from that horizontal pipe, and this thing will be 8 foot of it sticking up out of the concrete. So I think it's going to work out a lot better having the bottom being flat as opposed to just posts. I don't know if it'll make any difference, but I know if I was putting that in the hole and I was trying to throw things under it and shim it up to get it where it needed to be, having a couple of flat skids on the bottom, I think would be better. So I got those cut, and I'm going to clean those up and weld them on there, and then we'll take another look. Got the I-beams on the bottom here that I talked about. So that's going to make the bottom flat, like I was saying. Here's where I did some cleanup on the outside. And I ran the sander around where I saw spatter and stuff, just running around. So the next doozins we're going to get done on this has to do with setting the clearance height. And it's something that, you know, a vehicle's going to be pulling up from this side. And I'm just, on this side, I'm just going to probably weld a chain link about here and there. Where that chain link is on that side, they'll be hanging a piece of PVC pipe that would provide you a warning your vehicle would hit that piece of PVC pipe if your vehicle was too tall to fit into the car wash. So that would be a let you know without any harm done. The next thing on the next pipe, this one, if you hit the plastic PVC and continue to drive, I'm going to have a steel pipe. We'll be putting a steel pipe here made out of this 2-inch. And if you hit, if you drive past the plastic, the roof of your vehicle would smash into this steel pipe. Basically, you've been warned. Now you're going to hit your vehicle and damage your vehicle so that you don't go in there and damage the car wash kind of thing, is what we're talking about. So here's the thing about the way this is going to be set in place and concrete poured. I can't set this elevation for that bar right now, but I want to do whatever prefabrication work I can to make it easier down there. And here's what I suggest I do. I'm going to make this, I'm going to go ahead and fabricate. Okay, if you just imagine, here's our pay station roof. I'm going to go ahead and fabricate a 2-inch pipe shaped like that. And I'm going to let these vertical ends run long. So I'll be taking a piece of 2-inch pipe, cutting 45-degree miters, welding those 3 pieces together, and letting this pipe and this pipe run longer than I think I need. The next thing I'll do is over here, once that piece is made and I know what size it is, over here on this pipe, I'm going to cut holes in the 4-inch pipe that those vertical 2-inch pipes would go into. So by cutting a hole in this, that 2-inch pipe will go in, what that's going to allow us to do, once the concrete's poured and we can actually get a measurement on where we want this bar, I can go out there and I can take a rough measurement and I could cut the vertical bars of my 2-inch pipe where they'll fit up inside this 4-inch pipe somewhere, shoving it up in that hole. You see what I'm getting at? When that 2-inch pipe shoves into the 4-inch pipe, we can still go up and down just a wee whisker to make a final adjustment, meaning that we'll actually be able to shove that up inside of there and then measure from the bottom of that 2-inch pipe very accurately to the concrete at whatever clearance is going to be the absolute maximum, to the point of saying, we're not going to let you in the car wash if you're taller than this, and then weld. I think that's going to be the easiest thing to do. And the technique of shoving a smaller pipe into a larger pipe is something I've used a lot on fences, gates, things like that, because it gives you that adjustment, and you also don't have to fit a coat. So that's what we're doing. Here we go again, making another layout on the table. Give me something to go by. Let me draw my angle. Then I use a bevel square and use the bevel square to set my saw so I can cut my pipes on the angle that I need. And then I can lay them on the layout like I did there and see if that angle is going to work. Then the layout also helped me mark the length. And we're going to be cutting these off later, but I want them symmetrical. So the length kind of does matter, even though they will be getting cut off later. Then I just weld them up, and that makes up the bar that we need. Once I've got that bar made, I just hold it up onto the piece where it's going to go. Get some marks on the pay station structure there. I'm going to cut these holes. That'll allow me to shove that up inside of there. So even when we get a measurement and I know how much to cut off those, when I stick it up inside that pipe, I'm still going to be able to have an inch or two of adjustment up and down. And it's a good way to fit that together in this case. Brought that out here and set it on the trailer. We got that pipe fabricated. It'll be ready to put in. Got the holes put in where it's going to go. I welded those links on there. That means tomorrow we can start cutting the bar grating for the trough in the wash bay. That's pretty much it for the pay station for now. Gonna get a piece of bar grating cut and run it down there and stick it in the trough at the car wash. You'll notice right here when I'm cutting, I'm getting a little bit of binding. That happens with this bar grating. If there's tension that squeezes on your blade, best way I've found to deal with it is just back off and come back into your cut again. You've got to cut enough material out of the way to allow room for your blade to pass through. Trying out this grating actually in the concrete trough, and since there's a little bit of difference in the concrete, I'd asked my buddies, you know, do you want me to cut all of these by the minimum dimension and some of them are going to be loose, or would you want me to actually cut some of them a little longer than the other ones? I'm using a ratchet strap there, like you can see me pulling it up and down the trough. That gives us it gives us an easy way to see what that size bar grating would look like anywhere in the trough. And dragging it with that piece of strap like I'm doing, that's just a little bit easier than picking it up and laying it in different places. Now, they decided that on this side closest to us, where there's a little bit more space, they do want me to cut those grates a little bigger, so that's what we're going to do. Got the super service truck. Got the pay station structure roof. Got the bar grating. Got the vacuum holster brackets fabricated. Got the Art Captain MiG 200. We're headed to the car wash. I'll talk on the way. Getting the new vacuum holsters put into position with the Art Captain MiG 200 and the 035 Art Captain flux core wire. I lean that down a little bit on purpose and put a tack on the top. That way I can put a level on it, raise it up just a hair, put a tack on the bottom, check it left and right, and we're good. This is the first one, and I go ahead and get it right. And there's a little gap on the sides of those because that's not really cope fit with that 1-inch pipe going on to the 4-inch pipe. It's pretty tight at the top and bottom, gap at the side. So I'm doing all these with a downhill weld. Worked out really well. Having that gap running downhill, good penetration, decent looking weld. Plenty of what it's going to take to hold that vacuum, the vacuum holster with that vacuum hose on it. This is a quick video of me just moving on down the line with that Art Captain MiG 200, putting on all 4 of them and getting it done. That MiG 200 with the Art Captain wire did a nice job on that. I was tweaking on the heat as I went. I started out pretty hot, and you can run that wire hot, and it welds good hot. What I noticed though, when you're running it hot, you're more likely to get some porosity. You hit a little bit of contamination of any sort, and I think it's an excessive amount of popping force of it flying out of there, and that causes a little bit of surface porosity, and that doesn't happen near as bad when you turn it down just a little bit. These grates, these 4 down here, are just a little bit longer than those up there. I asked my buddy if he wanted me to go with the shorter dimension and make them all the same. And he said, no, if it's a little bigger down there, make those a little longer. Because when he takes these out and cleans this out, what he's thinking is he's just going to like pull that grate and just lay it right there, pull that one and lay it right there. So he's thinking it's not going to be a big deal to get them put back in the same place that they were took out. But I'll tell you one thing I did. On these ones that are shorter near the road, I put a little piece of stainless wire. All four of these that are a little bit shorter, they all have that little stainless wire. And that should stay on there forever and be an indicator that those are the shorter ones. Boy, a day like today when it's pretty, it's one car after another going through that car wash. We're going to call it done for now. Obviously, you know, there's going to be more stuff that's going to need done. Here at the car wash. Got some stainless fabrication that's coming up that's going to be going on for that, but this is the end of this one for now, and we'll get back on, and I'll show you that stainless too when we get to that. There's a 1-inch stainless pipe we're going to fabricate, and I'll be trying that Arc Captain flux core stainless wire. So stay tuned for that, and y'all, I want to thank you for watching, and learn how to work with what you got. That way you always have everything you need. Hey y'all, CB here in the break room at NBS Welding, coming to you with another merch video. Want to look at the merchandise, show you what we got. You can help support the channel by buying items. We got the NBS Welding t-shirts, got the NBS Welding on the chest on the front, got the great big NBS Welding here on the back, got the American flag on the sleeve. $25 plus shipping. Send Tina an email if you'd be interested in buying a t-shirt. $25 plus shipping. Send Tina an email, nbswelding@aol.com. The stickers. Got the small size stickers, $3. Medium sticker, $5. The big bumper stickers, $10. The coins, .999 fine silver. If you'd be interested in investing in the silver coin, got NBS Welding name and phone number on the front. Got the bull logo on the back. $50. $50 for the coins. Also with the coins, we've got the plastic case. Keeps the silver nice. Keeps it from getting fingerprinted and all that scratched up. The NBS Welding cups. Got the NBS Welding cups with the bull logo, and it says less yakking, more tacking. Got the QR code on the top. You can scan that. It'll take you to the NBS Welding YouTube channel. $27 for a cup. And I've had somebody said that I should sign the cups. I'm not doing that yet. I don't know if you want me to do that or not. But if you want a cup and you want me to sign it, I'll take a Sharpie and I'll sign it. I'll write whatever you want on there. Let us know. Send us an email. nbswelding@aol.com. Email Tina. And I'm not wearing an NBS shirt. I'm wearing a Kretschmer Excavating shirt. These are my buddies up in northeastern PA. If you need excavation work done in Wayne County, northeastern PA area, get a hold of my guy Cody up there. He can dig it. All right. I want to thank y'all for watching the NBS Welding YouTube channel. I appreciate all the support. Please continue to support, like, subscribe to videos, comment on the videos. If you don't have a comment, just go to the comment section, hit any letter, number, the period, whatever. The algorithm doesn't know the difference. Just, you know, that helps support the channel. It helps get the videos out there. And y'all learn how to work with what you got. That way you always have everything you need.